This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information and to find out how you can volunteer, please visit LibriVox.org. Recorded by Chip in Tampa, Florida on February 1st, 2006. The origin of species by means of natural selection or the preservation of favored races in the struggle for life. 6th London edition by Charles Darwin. Chapter 13. Geographical Distribution Continued. Distribution of freshwater productions. On the inhabitants of oceanic islands. Absence of batrachians and of terrestrial mammals. On the relation of the inhabitants of islands to those of the nearest mainland. On colonization from the nearest sources with subsequent modification. And summary of the last and present chapters. Freshwater productions. As lakes and river systems are separated from each other by barriers of land, it might have been thought that freshwater productions would not only have ranged widely within the same country, and as the sea is apparently a still more formidable barrier, that they would never have extended to distant countries. But the case is exactly the reverse. Not only have many freshwater species belonging to different classes an enormous range, but allied species prevail in a remarkable manner throughout the world. When first collecting in the fresh waters of Brazil, I well remember feeling much surprise at the similarity of the freshwater insects, shells, etc., and at the dissimilarity of the surrounding terrestrial beings compared with those of Britain. But the wide-ranging power of freshwater productions can, I think, in most cases, be explained by their having become fitted, in a manner highly useful to them, for short and frequent migrations from pond to pond, or from stream to stream within their own countries, and liability to wide dispersal would follow from this capacity as an almost necessary consequence. We can here consider only a few cases. Of these, some of the most difficult to explain are presented by fish. It was formerly believed that the same freshwater species never existed on two continents distant from each other. But Dr. Gunther has lately shown that the Galaxias attenuatus inhabits Tasmania, New Zealand, the Falkland Islands, and the mainland of South America. This is a wonderful case, and probably indicates dispersal from an Antarctic center during a formerly warm period. This case, however, is rendered in some degree less surprising by the species of this genus having the power of crossing, by some unknown means, considerable spaces of open ocean. Thus, there is one species common to New Zealand and to the Auckland Islands, although separated by a distance of about 230 miles. On the same continent, freshwater fish often range widely, and as if capriciously, for in two adjoining river systems some of the species may be the same, and some wholly different. It is probable that they are occasionally transported by what may be called accidental means. Thus, fishes still alive are not very rarely dropped at distant points by whirlwinds, and it is known that the ova retain their vitality for a considerable time after removal from the water. Their dispersal may, however, be mainly attributed to changes in the level of land within the recent period, causing rivers to flow into one another. Instances also could be given of this having occurred during floods without any change of level. The wide differences of the fish on the opposite sides of most mountain ranges, which are continuous, and consequently must from an early period have completely prevented the inosculation of the river systems on the two sides, leads to the same conclusion. Some freshwater fish belong to very ancient forms, and in such cases there will have been ample time for great geographical changes, and consequently time and means for much migration. Moreover, Dr. Gunther has been recently led by several conclusions to infer that, with fishes, the same forms have a long endurance. Saltwater fish can, with care, be slowly accustomed to live in fresh water, and, according to Valenciennes, there is hardly a single group of which all the members are confined to fresh water, so that a marine species belonging to a freshwater group might travel far along the shores of the sea, and could, it is probable, become adapted without too much difficulty to the fresh waters of a distant land. Some species of freshwater shells have very wide ranges, and allied species which, on our theory, are descended from a common parent, and must have proceeded from a single source, prevail throughout the world. Their distribution at first perplexed me, much as their ova are not likely to be transported by birds, and the ova as well as the adults are immediately killed by salt water. I could not even understand how some naturalized species have spread rapidly throughout the same country. But two facts which I have observed, and many others no doubt will be discovered, throw some light on this subject. When ducks suddenly emerge from a pond covered with duckweed, I have twice seen these little plants adhering to their backs, and it has happened to me in removing a little duckweed from one aquarium to another that I have unintentionally stocked the one with freshwater shells from the other. But another agency is perhaps more effectual. I suspended the feet of a duck in an aquarium, where many ova of freshwater shells were hatching, and found that numbers of the extremely minute and just hatched shells crawled on the feet, and clung to them so firmly that, when taken out of the water, they could not be jarred off, though at a somewhat more advanced stage they would voluntarily drop off. These just hatched mollusks, though aquatic in their nature, survived on the duck's feet in damp air from 12 to 20 hours, and in this length of time a duck or heron might fly at least 600 or 700 miles, and, if blown across the sea, to an oceanic island, or to any other distant point, would be sure to alight on a pool or rivulet. Sir Charles Lyell informs me that a Dictyus has been caught with an ancylus, a freshwater shell like a limpet, firmly adhering to it. And a water beetle of the same family, a Colymbetes, once flew aboard the Beagle when 45 miles distant from the nearest land. How much farther it might have been blown by a favoring gale, no one can tell. With respect to plants, it has long been known what enormous ranges many freshwater and even marsh species have, both over continents and to the most remote oceanic islands. This is strikingly illustrated, according to Alphonse de Candolle, in those large groups of terrestrial plants which have very few aquatic members, for the latter seem immediately to acquire, as if in consequence, a wide range. I think favorable means of dispersal explain this fact. I have mentioned before that earth occasionally adheres in some quantity to the feet and beaks of birds. Wading birds, which frequent these muddy edges of ponds, if suddenly flushed, would be the most likely to have muddy feet. Birds of this order wander more than those of any other, and are occasionally found on the most remote and barren islands of the open ocean. They would not be likely to alight on the surface of the sea, so that any dirt their feet would not have been washed off, and when gaining the land they would be sure to fly to their natural freshwater haunts. I do not believe that botanists are aware how charged the mud of ponds is with seeds. I have tried several little experiments, but will here give only the most striking case. I took in February 3 tablespoonsful of mud from 3 different ponds, beneath water, on the edge of a little pond. This mud, when dry, weighed only 7 3/4 ounces. I kept it covered up in my study for 6 months, pulling up and counting each plant as it grew. The plants were of many kinds, and altogether 537 in number, and yet the viscid mud was all contained in a breakfast cup. Considering these facts, I think it would be an inexplicable circumstance if water birds did not transport the seeds of freshwater plants to unstocked ponds and streams, situated at very distant points. This same agency may have come into play with the eggs of some of the smaller freshwater animals. Other and unknown agencies probably also have played a part. I have stated that freshwater fish eat some kinds of seeds, though they reject many other kinds after having swallowed them. Even small fish swallow seeds of moderate size, as of the yellow water lily and the tomicaton. Herons and other birds, century after century, have gone on daily devouring fish. They then take flight and go on to other waters, or are blown across the sea, and we have seen that seeds retain their power of germination when rejected many hours afterwards in pellets or in the excrement. When I saw the great size of the seeds of the fine water lily, the nebulum, I remembered Alphonse de Candole's remarks on the distribution of this plant, and I thought that the means of its dispersal must remain inexplicable. But Audubon states that he found the seeds of the great southern water lily, probably, according to Dr. Hooker, the Nebulum luteum, in a heron's stomach. Now, this bird must often have flown with its stomach thus, well stocked, to distant ponds, and then, getting a hearty meal of fish, analogy makes me believe that it would have rejected the seeds in the pellet in a fit state for germination. In considering these several means of distribution, it should be remembered that when a pond or stream is first formed, for instance on a rising islet, it will be unoccupied, and a single seed or egg will have a good chance of succeeding. Although there will always be a struggle for life between the inhabitants of the same pond, however few in kind, yet as the number even in a well-stocked pond is small in comparison with the number of species inhabiting an equal area of land, the competition between them will probably be less severe than between terrestrial species. Consequently, an intruder from the waters of a foreign country would have a better chance of seizing on a new place than is the case in terrestrial colonists. We should also remember that many freshwater productions are low in the scale of nature, and have reason to believe that such beings become modified more slowly than the high, and this will give time for the migration of aquatic species. We should not forget the probability of many freshwater forms having formerly ranged continuously over immense areas, and then having become extinct at intermediate points. But the wide distribution of freshwater plants and of the lower animals, whether retaining the same identical form or in some degree modified, apparently depends in main part on the wide dispersal of their seeds and eggs by animals, more especially by freshwater birds, which have the powers of flight and naturally travel from one place of water to another. On the inhabitants of oceanic islands. We now come to the last of the three classes of facts which I have selected as presenting the greatest amount of difficulty with respect to distribution, on the view that not only all of the individuals of the same species have migrated from some one area, but that allied species, although now inhabiting the most distant points, have proceeded from a single area, the birthplace of their early progenitors. I have already given my reasons for disbelieving in continental extensions within a period of existing species on so enormous a scale that all the many islands of the several oceans were thus stocked with their present terrestrial inhabitants. This view removes many difficulties, but it does not accord with all the facts in regard to the productions of the islands. In the following remarks I shall not confine myself to the mere question of dispersal, but shall consider some other cases bearing on the truth of the two theories of independent creation and of descent with modification. The species of all kinds which inhabit oceanic islands are few in number compared with those on equal continental areas. Alphonse de Candolle admits this for plants, and Wollaston for insects. New Zealand, for instance, with its lofty mountains and diversified stations extending over 780 miles of latitude, together with the outlying islands of Auckland, Campbell, and Chatham, contain altogether only 960 kinds of flowering plants. If we compare this moderate number with the species which swarm over equal areas in southwestern Australia or at the Cape of Good Hope, we must admit that some cause, independently of different physical conditions, has given rise to so great a difference in number. Even the uniform county of Cambridge has 847 plants, and the little island of Anglesey 764. But a few ferns and a few introduced plants are included in these numbers, and the comparison in some other respects is not quite fair. we have evidence that the barren island of Ascension aboriginally possessed less than half a dozen flowering plants, and yet many species have now become naturalized on it, as they have in New Zealand and on every other oceanic island which can be named. In St. Helena, there is reason to believe that naturalized plants and animals have nearly or quite exterminated many native populations. He who admits the doctrine of the creation of each separate species will have to admit that a sufficient number of the best adapted plants and animals were not created for oceanic islands, for man has unintentionally stocked them far more fully and perfectly than did nature. Although in oceanic islands the species are few in number, the proportion of endemic kinds, i.e. those found nowhere else in the world, is often extremely large. If we compare, for instance, the number of endemic land shells in Madeira, or of endemic birds in the Galapagos archipelago, with the number found on any continent, and then compare the area of the island with that of the continent, we shall see that this is true. This fact might have been theoretically expected, for, as already explained, species occasionally arriving after long intervals of time in the new and isolated district, and having come to compete with new associates, would be eminently liable to modification, and would often produce groups of modified descendants. But it by no means follows that, because in an island nearly all of the species of one class are peculiar, those of another class or of another section of the same class are peculiar, and this difference seems to depend partly on the species which are not modified having immigrated in a body, so that their mutual relations have not been much disturbed, and partly on the frequent arrival of unmodified immigrants from the mother country, with which the insular forms have been intercrossed. It should be borne in mind that the offspring of such crosses would certainly gain in vigor, so that even an occasional cross would produce more effect than might have been anticipated. I will give a few illustrations of the foregoing remarks. In the Galapagos Islands there are 26 land birds. Some of these 21, or perhaps 23, are peculiar, whereas of the 11 marine birds only 2 are peculiar, and it is obvious that marine birds could arrive at these islands much more easily and frequently than land birds. Bermuda, on the other hand, which lies at about the same distance from North America as the Galapagos do from South America, and which has a very peculiar soil, does not possess a single endemic land bird, and we know from J.M. Jones' admirable account of Bermuda that very many North American birds occasionally or even frequently visit this island. Almost every year, as I am informed by Mr. E.V. Harcourt, many European and African birds are blown to Madeira. This island is inhabited by 99 kinds, of which one alone is peculiar, though very closely related to a European form, and 3 or 4 other species are confined to this island and to the Canaries, so that the islands of Bermuda and Madeira have been stocked from neighboring continents with birds, which for long ages have there struggled together, and have become mutually co-adapted. Hence, when settled in their new homes, each kind will have been kept by the others to its proper place and habits, and will consequently have been but little liable to modification. Any tendency to modification will also have been checked by intercrossing with the unmodified immigrants, often arriving from the mother country. Madeira again is inhabited by a wonderful number of peculiar land shells, whereas not one species of sea-shell is peculiar to its shores. Now, though we do not know how sea-shells are dispersed, yet we can see that their eggs or larvae, perhaps attached to seaweed or floating timber, or to the feet of wading birds, might be transported across 300 or 400 miles of open sea far more easily than land shells. The different orders of insects inhabiting Madeira present nearly parallel cases. Oceanic islands are sometimes deficient in animals of certain whole classes, and their places are occupied by other classes. Thus, in the Galapagos Islands, reptiles, and in New Zealand gigantic wingless birds, take, or recently took, the place of mammals. Although New Zealand is here spoken of as an oceanic island, it is in some degree doubtful whether it should be so ranked. It is of large size, and it is not separated from Australia by a profoundly deep sea. From its geological character and the direction of its mountain ranges, the Rev. W. B. Clarke has lately maintained that this island, as well as New Caledonia, should be considered as appurtenances of Australia. Turning to plants, Dr. Hooker has shown that in the Galapagos Islands the proportional numbers of the different orders are very different from what they are elsewhere. All such differences in number, and the absence of certain whole groups of animals and plants, are generally accounted for by supposed differences in the physical conditions of the islands. But this explanation is not a little doubtful. Facility of immigration seems to be fully as important as the nature of the conditions. Many remarkable little facts could be given with respect to the inhabitants of oceanic islands. For instance, in certain islands not tenanted by a single mammal, some of the endemic plants have beautifully hooked seeds. Yet few relations are more manifest than that hooks serve for the transportation of seeds in the wool or fur of quadrupeds. But a hooked seed might be carried to an island by another means. The plant there becoming modified would form an endemic species, still retaining its hooks, which would form a useless appendage, like the shriveled wings under the soldered wing covers of many insular beetles. Again, islands often possess trees or bushes belonging to orders which elsewhere include only herbaceous trees. Now trees, as Alphonse de Candolle has shown, generally have, whatever the cause may be, confined ranges. Hence trees would be little likely to reach distant oceanic islands, and an herbaceous plant, which had no chance of successfully competing with the many fully developed trees growing on a continent, might, when established on an island, gain an advantage over other herbaceous plants by growing taller and overtopping them. In this case, natural selection would tend to add to the stature of the plant, to whatever order it belonged, and thus first convert it into a bush and then into a tree. Absence of batrachians and terrestrial mammals on oceanic islands. With respect to the absence of whole orders of animals on oceanic islands, Bory St. Vincent long ago remarked that batrachians, frogs, toads, newts, etc., are never found on any of the main islands with which the great oceans are studded. I have taken pains to verify this assertion, and have found it true, with the exception of New Zealand, New Caledonia, and the Andaman Islands, and perhaps the Solomon Islands and the Seychelles. But I have already remarked that it is doubtful whether New Zealand and New Caledonia ought to be classed as oceanic islands, and this is still more doubtful with respect to the Andaman and Solomon groups and the Seychelles. This general absence of frogs, toads, and newts on so many true oceanic islands cannot be accounted for by their physical conditions. Indeed, it seems that islands are peculiarly fitted for these animals, for frogs have been introduced into Madeira, the Azores, and Mauritius, and have multiplied so as to become a nuisance. But as these animals and their own spawn are immediately killed, with the exception, as far as known, of one Indian species, by sea water, there would be great difficulty in their transportal across the sea, and therefore we can see why they do not exist on strictly oceanic islands. Mammals offer another and similar case. I have carefully searched the oldest voyages, and have not found a single incident, free from doubt, of a terrestrial mammal, excluding domesticated animals kept by the natives, inhabiting an island situated above 300 miles from a continent or great continental island, and many islands situated at a much less distance are equally barren. The Falkland Islands, which are inhabited by a wolf-like fox, comes nearest to an exception, but this group cannot be considered as oceanic, as it lies on a bank in connection with the mainland of a distance of about 280 miles. Moreover, icebergs formerly brought boulders to its western shores, and they may have formerly transported foxes, as now frequently happens in the Arctic regions. Yet it cannot be said that small islands will not support at least small mammals, for they occur in many parts of the world on very small islands, and when lying close to a continent, and hardly an island can be named on which our smaller quadrupeds have not become naturalized and greatly multiplied. It cannot be said, on the ordinary view of creation, that there has not been time for the creation of mammals. Many oceanic islands are sufficiently ancient, as shown by the stupendous degradation they have suffered, and by their tertiary strata. There has also been time for the production of endemic species belonging to other classes, and on continents it is known that new species of mammals appear and disappear at a quicker rate than other and lower animals. Although terrestrial mammals do not occur on oceanic islands, aerial mammals do occur on almost every island. New Zealand possesses 2 bats found nowhere else in the world. Norfolk Island, the Viti Archipelago, the Bonin Islands, the Caroline and Marianne Archipelagos, and Mauritius all possess their peculiar bats. Why, it may be asked, has this supposed creative force produced bats and no other mammals on remote islands? On my view, this question can easily be answered, for no terrestrial mammal can be transported across a wide space of sea, but bats can fly across. Bats have been seen wandering by day far over the Atlantic Ocean, and 2 North American species either regularly or occasionally visit Bermuda, at a distance of 600 miles from the mainland, and I hear from Mr. Tomes, who has specially studied this family, that many species have enormous ranges, and are found on continents and far distant islands. Hence we have only to suppose that such wandering species have been modified in their new homes in relation to their new position, and we can understand the presence of endemic bats on oceanic islands with the absence of all other terrestrial animals. Another interesting relation exists between the depth of the sea separating islands from each other, or from the nearest continent, and the degree of affinity of their mammalian inhabitants. Mr. Windsor Earle has made some striking observations on this head, since greatly extended by Mr. Wallace's admirable researches, in regard to the great Malay Archipelago, which is traversed near the Celebes by a space of deep ocean, and this separates 2 widely distinct mammalian faunas. On either side the islands stand on a moderately shallow submarine bank, and these islands are inhabited by the same or by closely allied quadrupeds. I have not as yet had time to follow up on this subject in all quarters of the world, but as far as I have gone the relation holds good. For instance, Britain is separated by a shallow channel from Europe, and the mammals are the same on both sides. So it is with all the islands near the shores of Australia. The West Indian islands, on the other hand, stand on a deeply submerged bank, nearly 1,000 fathoms in depth, and here we find American forms, but the species and even the genera are quite distinct. As the amount of modification which animals of all kinds undergo partly depends on the lapse of time, and as the islands which are separated from each other or from the mainland by shallow channels are more likely to have been continuously united within a recent period than the islands separated by deeper channels, we can understand how it is that a relation exists between the depth of the sea separating 2 mammalian faunas and the degree of their affinity, a relation which is quite inexplicable on the theory of independent acts of creation. The foregoing statements in regard to the inhabitants of oceanic islands, namely the fewness of the species, with a large proportion consisting of endemic forms, the members of certain groups, but not those of other groups in the same class, having been modified, the absence of certain whole orders, as of bactrians and of terrestrial animals, notwithstanding the presence of aerial bats, the singular proportions of certain orders of plants, herbaceous forms having been developed into trees, etc., seem to me to accord better with the belief in the efficiency of occasional means of transport carried on during a long course of time, than with the belief in the former connection of all oceanic islands with the nearest continent. For on this latter view it is probable that the various creatures would have immigrated more uniformly, and from the species having entered as a body, their mutual relations would not have been much disturbed, and consequently they would either not have been modified, or all of the species in a more equable manner. I do not deny that there are many and serious difficulties in understanding how many of the inhabitants of the more remote islands, whether still retaining some of the specific form or subsequently modified, have reached their present homes. But the probability of other islands having once existed as a halting place, of which not a wreck now remains, must not be overlooked. I will specify one difficult case. Almost all oceanic islands, even the most isolated and smallest, are inhabited by land shells, generally by endemic species, but sometimes by species found elsewhere, striking instances of which have been given by Dr. A. Gould in relation to the Pacific. Now it is notorious that land shells are easily killed by sea water. Their eggs, at least such as I have tried, sink in it and are killed. Yet there must be some unknown but occasionally efficient means for their transportal. Would the just hatched young sometimes adhere to the feet of birds roosting on the ground, and thus get transported? It occurred to me that land shells, when hibernating and having a membranous diaphragm over the mouth of the shell, might be floated in chinks of drifted lumber across moderately wide arms of the sea. And I find that several species in this state withstand uninjured an immersion in sea water during 7 days. One shell, the Helix pomatia, after having been thus treated and again hibernating, was put into sea water for 20 days and perfectly recovered. During this length of time the shell might have been carried by a marine current of average swiftness to a distance of 660 geographical miles. As this helix has a thick calcareous operculum, I removed it, and when it had formed a new membranous one, I again immersed it for 14 days in sea water, and again it recovered and crawled away. Baron Aucapitaine has since tried similar experiments. He placed 100 land shells, belonging to 10 species, in a box pierced with holes, and immersed it for a fortnight in the sea. Out of the 100 shells, 27 recovered. The presence of an operculum seems to have been of importance, as out of 12 specimens of Cyclostoma elegans, which is thus furnished, 11 survived. It is remarkable, seeing how well the Helix pomatia resisted with me the salt water, that not one of 54 specimens belonging to 4 other species of Helix tried by Aucapitaine recovered. It is, however, not at all probable that land shells have often been thus transported. The feet of birds offer a more probable method. On the relations of the inhabitants of islands to those of the nearest mainland. The most striking and important fact for us is the affinity of the species which inhabit islands to those of the nearest mainland, without being actually the same. Numerous species could be given. The Galapagos archipelago, situated under the equator, lies at a distance of between 500 and 600 miles from the shores of South America. Here almost every product of the land and the water bears the unmistakable stamp of the American continent. There are 26 land birds. Of these, 21 or perhaps 23 are ranked as distinct species, and would commonly be assumed to have been there created. Yet the close affinity of most of these birds to American species is manifest in every character of their habits, gestures, and tones of voice. So it is with the other animals, and with a large proportion of the plants, as shown by Dr. Hooker in his admirable Flora of this Archipelago. The naturalist, looking at the inhabitants of these volcanic islands in the Pacific, distant several hundred miles from the continent, feels that he is standing on American land. Why should this be so? Why should the species which are supposed to have been created in the Galapagos Archipelago and nowhere else bear so plainly the stamp of affinity to those created in America? There is nothing in the conditions of life, in the geological nature of the islands, in their height or climate, or in the proportions in which the several classes are associated together, which closely resembles the conditions of the South American coast. In fact, there is a considerable dissimilarity in all of these respects. On the other hand, there is a considerable degree of resemblance in the volcanic nature of the soil, in the climate, height, and size of the islands between the Galapagos and Cape Verde archipelagos. But what an entire and absolute difference in their inhabitants! The inhabitants of the Cape Verde Islands are related to those of Africa, like those of the Galapagos to America. Facts such as these admit of no sort of explanation on the ordinary view of independent creation. Whereas on the view here maintained, it is obvious that the Galapagos Islands would be likely to receive colonists from America, whether by occasional means of transport, or, though I do not believe in this doctrine, by formerly continuous land, and the Cape Verde Islands from Africa. Such colonists would be liable to modification, the principle of inheritance still betraying their original birthplace. Many analogous facts could be given. Indeed, it is an almost universal rule that the endemic productions of islands are related to those of the nearest continent, or of the nearest large island. The exceptions are few, and most of them can be explained. Thus, although Kerguelen Land stands nearer to Africa than to America, the plants are related, and that very closely, as we know from Dr. Hooker's account, to those of America. But on the view that this island has been mainly stocked by seeds brought within earth and stones on icebergs, drifted by the prevailing currents, this anomaly disappears. New Zealand, in its endemic plants, is much more closely related to Australia, the nearest mainland, than to any other region, and this is what might have been expected, but it is also plainly related to South America, which, although the next nearest continent, is so enormously remote that the fact becomes an anomaly. But this difficulty partially disappears on the view that New Zealand, South America, and other southern lands have been stocked in part from a nearly indeterminate though distant point, namely from the Antarctic lands, when they were clothed with vegetation during a warmer tertiary period, before the commencement of the last glacial period. The affinity, which, though feeble, I am assured by Dr. Hooker is real, between the flora of the southwestern corner of Australia and of the Cape of Good Hope, is a far more remarkable case, but this affinity is confined to the plants, and will, no doubt, some day be explained. The same law which has determined the relationship between the inhabitants of islands and the nearest mainland is sometimes displayed on a small scale, but in a most interesting manner within the limits of the same archipelago. Thus each separate island of the Galapagos archipelago is tenanted, and the fact is a marvelous one, by many different species. But these species are related to each other in a very much closer manner than the inhabitants of the American continent, or of any other quarter of the world. This is what might have been expected for islands situated so near to each other that they would almost necessarily receive immigrants from the same original source and from each other. But how is it that many of the immigrants have been differently modified, though only in a small degree, in islands situated within sight of each other, having the same geological nature, the same height, climate, etc.? This long appeared to me a great difficulty, but it arises in chief part from the deeply seated error of considering the physical conditions of a country as the most important, whereas it cannot be disputed that the nature of the other species with which it has to compete is at least as important, and generally a far more important element of success. Now, if we look to the species which inhabit the Galapagos archipelago, and are likewise found in other parts of the world, we find that they differ considerably in the several islands. This difference might indeed have been expected if the islands had been stocked by occasional means of transport, a seed, for instance, of one plant having been brought to one island, and that of another plant to another island, though all proceeding from the same general source. Hence, when in former times an immigrant first settled on one of the islands, or when it subsequently spread from one to another, it would undoubtedly be exposed to different conditions in the different islands, for it would have to compete with a different set of organisms. A plant, for instance, would find the ground best fitted for it occupied by a somewhat different species in the different islands, and would be exposed to the attacks of somewhat different enemies. If then it varied, natural selection would probably favor different varieties in the different islands. Some species, however, might spread and yet retain the same character throughout the group, just as we see some species spreading widely throughout a continent and remaining the same. The really surprising fact in this case of the Galapagos archipelago, and in a lesser degree in some analogous cases, is that each new species, after being formed on any one island, did not spread quickly to the other islands. But the islands, though within sight of each other, are separated by deep arms of the sea, in most cases wider than the British Channel, and there is no reason to suppose that they have at any former period been continuously united. The currents of the sea are rapid and deep between the islands, and gales of wind are extraordinarily rare, so that islands are far more effectually separated from each other than they appear on a map. Nevertheless, some of the species, both of those found on other parts of the world and of those confined to the archipelago, are common to the several islands, and we may infer from the present manner of distribution that they have spread from one island to the others. But we often take, I think, an erroneous view of the probability of closely allied species invading each other's territory, when put into free intercommunication. Undoubtedly, if one species has any advantage over another, it will in a very brief time wholly or in part supplant it. But if both are equally well fitted for their own places, both will probably hold their separate places for almost any length of time. Being familiar with this fact, that many species, naturalized through man's agency, have spread with astonishing rapidity over wide areas, we are apt to infer that most species would thus spread. But we should remember that the species which become naturalized in new countries are not generally closely allied to the aboriginal inhabitants, but are very different forms, belonging in a large proportion of cases, as shown by Alphonse de Candolle, to distinct genera. In the Galapagos archipelago, many even of the birds, though so well adapted for flying from island to island, differ on the different islands. Thus there are 3 closely allied species of mocking thrush, each confined to its own island. Now let us suppose the mocking thrush of Chatham Island to be blown to Charles Island, which has its own mocking thrush. Why should it succeed in establishing itself there? We may safely infer that Charles Island is well stocked with its own species, for annually more eggs are laid and young birds hatched than can possibly be reared; and we may infer that the mocking thrush peculiar to Charles Island is at least as well fitted for its home as the species peculiar to Chatham Island. Sir C. Lyell and Mr. Wollaston have communicated to me a remarkable fact bearing on this subject, namely, that Madeira and the adjoining islet of Porto Santo possess many distinct yet representative species of land snails, some of which live in crevices of stone, and although large quantities of stone are annually transported from Porto Santo to Madeira, yet this latter island has not become colonized by the Porto Santo species. Nevertheless, both islands have been colonized by some European land shells, which no doubt had some advantage over the indigenous species. From these considerations, I think we need not greatly marvel at the endemic species which inhabit the several islands of the Galapagos archipelago not having at all spread from island to island. On the same continent, also, pre-occupation has probably played an important part in checking the commingling of the species which inhabit different districts with nearly the same physical conditions. Thus the southeast and southwest corners of Australia have nearly the same physical conditions and are united by continuous land, yet they are inhabited by a vast number of distinct mammals, birds, and plants. So it is, according to Mr. Bates, with his butterflies and other animals inhabiting the great, open, and continuous valley of the Amazons. The same principle which governs the general character of the inhabitants of oceanic islands, namely the relation to the source whence the colonists could have most easily derived, together with their subsequent modification, is of the widest application throughout nature. We see this on every mountain summit, in every lake and marsh. For alpine species, excepting in as far as the same species have become widely spread during the glacial epoch, are related to those of the surrounding lowlands. Thus we have in South America alpine hummingbirds, alpine rodents, alpine plants, etc., all strictly belonging to American forms, and it is obvious that a mountain, as it became slowly upheaved, would be colonized from the surrounding lowlands. So it is that the inhabitants of lakes and marshes, excepting in so far as the great facility of transport has allowed the same forms to prevail throughout large portions of the world. We see the same principle in the character of most of the blind animals inhabiting the caves of America and Europe. Other analogous facts could be given. It will, I believe, be found universally true that wherever in two regions, let them be ever so distant, many closely allied or representative species occur, there will likewise be found some identical species, and wherever more closely allied species occur, there will be found many forms which some naturalists rank as distinct species, and others as mere varieties. These doubtful forms showing us the steps in the process of modification. The relation between the power and extent of migration in certain species, either at the present or at some former period, and the existence at remote points of the world of closely allied species, is shown in another and more general way. Mr. Gould remarked long ago that in those genera of birds which range over the world, many of the species have very wide ranges. I can hardly doubt that this rule is generally true, although difficult of proof. Among mammals we see it strikingly displayed in bats, and in a lesser degree in the Felidae and Canidae. We see the same rule in the distribution of butterflies and beetles. So it is with most of the inhabitants of fresh water, for many of the genera in the most distinct classes range all over the world, and many of the species have enormous ranges. It is not meant that all, but that some of the species have very wide ranges in the genera which range very widely. Nor is it meant that the species in such genera have, on average, a very wide range, for this will largely depend on how far the process of modification has gone. For instance, two varieties of the same species inhabit America and Europe, and thus the species has an immense range. But if a variation were to be carried a little further, the two varieties would be ranked as distinct species, and their range would be greatly reduced. Still less is it meant that the species which have the capacity of crossing barriers and ranging widely, as in the case of certain powerfully winged birds, will necessarily range widely, for we should never forget that to range widely implies not only the power of crossing barriers, but the more important power of being victorious in distant lands in the struggle for life with foreign associates. But according to the view that all the species of a genus, though distributed to the most remote points of the world, are descended from a single progenitor, we ought to find, and I believe as a general rule we do find, that at least some of the species range very widely. We should bear in mind that many genera in all classes are of ancient origin, and the species in this case will have had ample time for dispersal and subsequent modification. There is also reason to believe, from geological evidence, that within each class the lower organisms change at a slower rate than the higher. Consequently, they will have had a better chance of ranging widely and of still retaining the same specific character. This fact, together with that of the seeds and eggs of most lowly organized forms being very minute and better fitted for distant transportal, probably accounts for a law which has long been observed, and which has lately been discussed by Alphonse de Candolle in regard to plants, namely that the lower any group of organisms stands, the more widely it ranges. The relations just discussed, namely lower organisms ranging more widely than the higher, some of the species of widely ranging genera themselves ranging widely. Such facts as alpine, lacustrine, and marsh productions, being generally related to those which live on the surrounding lowlands and drylands, the striking relationship between the inhabitants of islands and those of the nearest mainland, the still closer relationship of the distinct inhabitants of the islands of the same archipelago, are inexplicable on the ordinary view of the independent creation of each species, but are explicable if we admit colonization from the nearest or readiest source, together with the subsequent adaptation of the colonists to their new homes. Summary of the last and present chapters. In these chapters I have endeavored to show that if we make due allowance for our ignorance of the full effects of changes of climate and of the level of the land, which have certainly occurred within the recent period, and of other changes which have probably occurred, if we remember how ignorant we are with respect to the many curious means of occasional transport, if we bear in mind, and this is a very important consideration, how often a species may have ranged continuously over a wide area, and then have become extinct in the intermediate tracts, the difficulty is not insuperable in believing that all the individuals of these same species, wherever found, are descended from common parents. And we are led to this conclusion, which has been arrived at by many naturalists under the designation of single centres of creation, by various general considerations, more especially from the importance of barriers of all kinds, and from the analogical distribution of subgenera, genera, and families. With respect to distinct species belonging to the same genus, which on our theory have spread from one parent source, if we make the same allowances as before for our ignorance, and remember that some forms of life have changed very slowly, enormous periods of time have been thus granted for their migration, the difficulties are far from insuperable, though in this case, as in that of the individuals of the same species, they are often great. As exemplifying the effects of climatical changes on distribution, I have attempted to show how important a part the last glacial period has played, which affected even the equatorial regions, and which, during the alternations of the cold in the north and the south, allowed the productions of opposite hemispheres to mingle, and left some of them stranded on the mountain summits in all parts of the world. As showing how diversified are the means of occasional transport, I have discussed at some little length the means of dispersal of freshwater productions. If the difficulties be not insuperable in admitting that in the long course of time all the individuals of the same species, and likewise of the several species belonging to the same genus, have proceeded from some one source, then all the grand leading facts of geographical distribution are explicable on the theory of migration, together with subsequent modification and the multiplication of new forms. We can thus understand the high importance of barriers, whether of land or water, in not only separating but in apparently forming the several zoological and botanical provinces. We can thus understand the concentration of related species within the same areas, and how it is that under northern latitudes, for instance in South America, the inhabitants of the plains and mountains of the forests, marshes, and deserts are linked together in so mysterious a manner, and are likewise linked to the extinct beings which formerly inhabited the same continent. Bearing in mind the mutual relation of organism to organism is of the highest importance, we can see why two areas, having nearly the same physical considerations, should often be inhabited by very different forms of life, for according to the length of time which has elapsed since the colonists entered one of the regions, or both according to the nature of the communication which allowed certain forms and not others to enter, either in greater or lesser numbers, according or not as those which entered happened to come into more or less direct competition with each other and with the aborigines, and according as the immigrants were capable of varying more or less rapidly, there would ensue in the two or more regions, independently of their physical conditions, infinitely diversified conditions of life. There would be an almost endless amount of organic action and reaction, and we should find some groups of beings greatly and some only slightly modified, some developed in great force, some existing in scanty numbers, and this we do find in the several great geographical provinces of the world. On these same principles we can understand, as I have endeavoured to show, why oceanic islands should have few inhabitants, but that of these a large proportion should be endemic or peculiar, and why, in relation to the means of migration, one group of beings should have all its species peculiar, and another group, even within the same class, should have all its species the same with those in an adjoining quarter of the world. We can see why whole groups of organisms, as batrachians and terrestrial animals, should be absent from oceanic islands, whilst the most isolated islands should possess their own peculiar species of aerial mammals or bats. We can see why in islands there should be some relation between the presence of mammals in a more or less modified condition and the depth of the sea between such islands and the mainland. We can clearly see why all of the inhabitants of an archipelago, though specifically distinct on the several islets, should be closely related to each other, and should likewise be related, but less closely, to those of the nearest continent or other source whence immigrants might have been derived. We can see why, if there exist very closely allied or representative species in two areas, however distant from each other, some identical species will almost always there be found. As the late Edwin Forbes often insisted, there is a striking parallelism in the laws of life throughout time and space, the laws governing the succession of forms in past times being nearly the same with those governing in the present time the differences in different areas. We see this in many facts. The endurance of each species and group of species is continuous in time, for the apparent exceptions to the rule are so few that they may fairly be attributed to our not having as yet discovered in our intermediate deposit certain forms which are absent in it, but which occur above and below. So in space it certainly is the general rule that the area inhabited by a single species or by a group of species is continuous, and the exceptions, which are not rare, may, as I have attempted to show, be accounted for by former migrations under different circumstances, or through occasional means of transport, or by the species having become extinct in the determinate tracts. Both in time and in space, species and groups of species have their points of maximum development. Groups of species, living through the same period of time, or living within the same area, are often characterized by trifling features in common, as of sculpture or colour. In looking to the long succession of past ages, as in looking to distant provinces throughout the world, we find that species in certain classes differ little from each other, while those in another class, or only in a different section of the same order, differ greatly from one another. In both time and space, the lowly organized members of each class generally change less than the highly organized, but there are in both cases marked exceptions to the rule. According to our theory, these several relations throughout time and space are intelligible, for whether we look to the allied forms of life which have changed during successive ages, or to those which have changed after having migrated into different quarters, in both cases they are connected by the same bond of ordinary generation. In both cases the laws of variation have been the same, and modifications have been accumulated by the same means of natural selection. So ends Chapter 13 of The Origin of Species by Charles Darwin.